Hey everybody, Mr. Taylor here. Today we're going to go through some of our notes on the skeletal system, and this will be part 2 of our skeletal system notes. So just a review from yesterday in case you missed it. We started just talking about the functions of the skeleton. So we just went over the 6 main functions of the skeletal system. And then we talked about the 5 different types of bones. So basically all of your 206 bones fit into one of these 5 classes. And so to get started, I made some warm-up questions. So just take a look at these for a minute, and you can pause the video and think about them. And then when you come back from answering the questions, unpause the video, and I'll give you the answers. Okay, so here's the answers to these questions. So the first one says, which part of a bone is involved in hematopoiesis? And if you forgot this from yesterday, hemato means blood, and apparently poiesis means production. So if you want to know which part of your body produces blood, it is your red bone marrow. And I think we talked about that in most classes yesterday, but if we didn't, it's your red bone marrow. Number 2 says, which part of the bone stores triglycerides? Triglycerides are another word for fat. So in this case, this is stored by another type of bone marrow called yellow bone marrow. And yellow bone marrow is yellow because it's fatty, kind of like butter, or if you've ever seen like, different fatty deposits are usually whitish or yellow in color. And then the example for each, and there's lots of different ones you could do. So a long bone, you could pick like the femur would be a great example, but you could have done like the humerus, you could have done the ulna, any of the longer bones of the limbs would work for this one. Short bone, there are only 2 types we talked about, the carpals and the tarsals. So if you named any one of those bones, that would work. Flat bones, there's a lot of these, are mostly in the axial skeleton. So you could have given me like ribs would have been a great example, scapula. You could also have done something like the parietal bone up in there in your skull, something like that. Lots and lots and lots of flat bones, and they're obviously flat. Irregular bones, the best example of this is the vertebrae, but you could have also given me like, some of the bones of the skull. And then finally, sesamoid, the only example that everyone has is a patella, but you could also talk about the other sesamoids that form inside your tendons in your hands or feet. Okay, so today we're going to talk about the macroscopic structure of a bone. And actually, we're going to talk about all the structure of a bone, but we're going to start with the macroscopic, and then we'll go down to the microscopic. So basically, when you look at a bone, so let's take a look at this illustration over here. This is a long bone, and we're going to use this as an example because it contains all the parts. All the other bones have the same parts with a couple exceptions. So there's a few parts that you may not find in a flat bone or in a short bone, but they're all found in the long bone. So the first part is what we call the diaphysis, and you can see that right here in our illustration. The diaphysis is the center of the bone, so you can see right to about here, the middle of the bone, and you can notice it's got some pretty thick compact bone, and it's got this hollow cavity. So we call the diaphysis the shaft of the bone because it's like the center kind of like long tube in the middle. Next to that, we have this thing called the epiphyses, and they're actually not like right next to it, but they're close. So here is an epiphysis on one end, and here's an epiphysis on the other, and you can see that there's a little line right here that kind of divides this. And so an epiphysis is kind of like what I would call like the end cap, and you should know this already. The prefix epi means on, so it's on the end, so this is like the end caps of the bone. And usually bones have one on a proximal end and one on a distal end in your long bones because, one's like closer to your body and one's farther away. The third thing we have on here is this thing called an epiphyseal line. And obviously, you can see these words look similar because it's related. The epiphyseal line is right up here, and it's this little line that goes right inside of the bone. And it's basically where the epiphysis and diaphysis connected. So once upon a time, there was a little bit of cartilage right along this kind of curved line, and that cartilage is what we call our growth plate. And so when you were growing up, you had a growth plate, or what we call an epiphyseal plate right there, and as an adult that disappears and is replaced by bone, and we call that an epiphyseal line. So this is kind of like your old growth plate is what we'll call this. It's where the epiphysis and diaphysis grew together. And in that same general region, we have this area called the metaphysis. And so the metaphysis is right in between the diaphysis and the epiphysis. It's kind of the transition. So if you notice, if you start on one end, you can see it's got thicker, more compact bone. And as you go out, it kind of widens out and becomes thinner and more spongy. And you can see there's another metaphysis down here on the distal end, and you can see how the bone kind of widens out as we go down here. So the metaphysis is, I always think of M in metaphysis for middle. So this is like the middle part between the diaphysis and the epiphysis. So it's in between those two parts. Great. Next we have this thing called the articular cartilage. And so if you look at this picture, you can see up here there's this kind of bluish like cap on the end of the bone, and you can see one down here too. So here's our articular cartilage. And the word articular means joint. So literally articular cartilage is the hyaline on the joint. So articular cartilage, we're just going to call this the joint cartilage, because that's what it is. And in parentheses, I'm going to write in hyaline, because that's the type of cartilage it is. So anyway, the articular cartilage is what wears down when you get arthritis, and it kind of like pads your bone and reduces the friction in the bone. Next we have this thing called the periosteum, and anytime we see the prefix peri, it always means like around, like a perimeter. And so this is a layer of dense irregular connective tissue, and you can see it right here in our diagram. And so the periosteum is kind of like your bone skin. That's what I like to call this. Bone skin. Because it's literally like the skin of your bone. So it covers the outside of the bone, and it's also what everything attaches to. So for example, like let's say you had like a muscle out here outside of the bone. This muscle, of course, would hook onto the bone using a tendon, and the tendon actually sticks onto the periosteum. So basically, the periosteum holds the tendon onto the bone, the tendon holds the muscle onto the periosteum, and these things all have to be linked up, because if anything tears when you move the muscle, then you're going to have big problems. So the periosteum is a very strong tissue, and we know dense irregular is strong in all directions, of course, so that makes sense. All right, getting down here to the home stretch, we have this thing called the medullary cavity. And so anytime we see something with medulla means in the middle or the center, and cavity, of course, means something empty. And so this is the hollow center of the bone. And so if we go back to our illustration and take a look here, we can see here is our medullary cavity, and it says contains yellow bone marrow. And so this is just this hollow part inside the diaphysis, and normally this would be filled with yellow bone marrow as a form of energy storage. And then finally we have this thing called the endosteum, and this is like the lining of the medullary cavity. So basically when you go inside of your medullary cavity, this is just the kind of lining, because it's endo, like inside. So the periosteum's on the outside, because peri means perimeter, endo means inside, so it's just kind of like a little bit of tissue lining the inside of the cavity. All right, so here's another picture. This is the same picture we had on the first slide, just without all my marks all over it. Whoops, there we go. And you can also see an actual bone over here. So here's a photograph. And in this bone, you can see all the different parts. So you can see where the diaphysis is, and you can see here's our epiphysis on the end, the metaphysis in between. You can see there's a lot of spongy bone inside of the bone. You can see there's compact bone here. You can see our medullary cavity. And so, you know, any one of your long bones, this happens to be a femur. And this illustration on the left happens to be a humerus, but any long bone will have all those parts. Okay, so that's the end of the macroscopic parts of the bone. Now we're going to move on to the microscopic structure of bone. And so if you were to look at a bone and break it down chemically, we find out that, whoops, I don't know why that keeps happening, about a quarter of your bone's mass is just water. So any bone you ever pick up, if you find a bone someplace, it's probably dried out and it's lost about 25% of its mass because the water evaporates. But you know, bones are alive, so they need water just like the rest of your body. About 25% of your bone is collagen, and of course we know that collagen is very strong. So from the collagen, we get strength, because it's the strongest protein in nature, and we also get some flexibility because, sorry, I can't spell and talk at the same time. So we get flexibility in collagen because it's a protein, and it's, have you ever seen a wallet? It's made from a cow's dermis. You know that dermis is dense irregular connective tissue, so all those collagen fibers forming a web make it strong in all directions. But also, just like leather is kind of flexible, the collagen inside your bones is flexible. And then we get mineral salts, which of course here we're talking about calcium. That's really what we're talking about. The bulk of this is calcium. And this is what gives it its hardness. Okay, so this is what makes bone a hard tissue, and it makes it very stiff. Unfortunately, that means it's also very brittle. So we get this hardness from calcium plus the strength and flexibility of collagen that makes it very, very, very strong. So that's why bone is like such a strong tissue, because we're getting strength from a protein and hardness from a hard mineral. It makes it very resilient to damage. And we need both of these. If you lose one or the other, you're going to have problems. Now, if we look at the cells, so that's the matrix part. If we look at the cells that make up your bones, take a look at this picture down here. So we start off with these things called pre-osteoblasts, and these are like our stem cells, basically. So way back in the day, before you had any bones, you had a bunch of stem cells. Those stem cells turn into these cells called osteoblasts. And of course, osteo means bone, and blast means to make. So it starts making the bone, and you can actually see this little off-white area here is the bone it's producing. Over time, those bone cells get kind of stuck inside of this kind of like forming bone that we call an osteoid, which is just like kind of as the bone's forming, and they get trapped inside. So they kind of make all this bone matrix and trap themselves, and eventually this osteoid hardens into a full-on bone, this mineral bone, and these cells are left trapped inside, and we call them osteocytes. So we start with an stem cell, which becomes an osteoblast, and an osteoblast eventually becomes an osteocyte when it's trapped. So that's going to bring us back over here. So osteogenic cells, these are the stem cells. Literally, osteo meaning bone, and genic meaning like to make. Okay, so this is going to be the cells that are going to be made into eventually the bone cells. So over time, those stem cells differentiate and become osteoblasts. And once again, osteo means bone, and blast means to make. So these are your bone making cells. And so they are in charge of making all of your new bone matrix. Over time, these osteoblasts, like we said, get trapped inside of the bone. And when they get trapped, they form osteocytes. And so these guys are trapped inside of your bone for life, pretty much. And these are our bone maintaining cells. So I'm just going to write on here that they maintain your bone. So basically, when you are, like let's say, for example, if you looked inside your bones, you would see a bunch of these osteocytes trapped in here. Now, let's say that you get in some sort of accident and something like breaks your bone and you have a bunch of like damage here. These osteocytes would wake up, repair that damage, and then kind of go back to sleep and just stay in there. So we have osteocytes just waiting for damage inside your bone to fix. The osteoblasts, on the other hand, are forming new bones. When your bones get larger and stronger, that's mostly from the osteoblasts. Now, separate from all of these, I'm just going to draw a line here. These three cells are all related. There's another type of bone cell called an osteoclast, and these guys are involved in breaking down bone. So we're going to say, break down bone. So just like we have cells that make bone and we have cells that maintain bone, we also have to have cells that are going to be able to break down our bone. And we call this process reabsorption, because we basically have calcium in our blood and it goes into our bones. So we're constantly like storing calcium from our blood and stick it into our bones. That's what our osteoblasts and osteocytes are doing. They're sticking all the calcium away and using it to make your bones stronger. But let's say we run low on calcium, we would then need a way to take calcium from our bones and put it back into our blood. And so that's the reabsorption we're talking about. So when we like put the calcium back into circulation, we call that reabsorption. Okay, so last little thing we have to talk about today is the structure of compact bone. And so there's two types of bone, basically. We have compact bone and spongy bone. And let me show you what that looks like. So if you were to look in the diaphysis of a long bone. All around the outside, we have what's called compact bone because it's very compact. It's very dense. There's no like real gaps. And then on the edges of that compact bone, and particularly in the ends of bones, like in the epiphyses, we see what's called spongy bone. And you can see it kind of looks like a sponge. So that's mostly like underneath. So when we look at compact bone, it's broken down to these things called osteons. And the osteon is kind of like a, well, I don't have anything to write here. It's just a round unit of bone. So let's go back and look at this illustration again. So inside of this compact bone, you can see there's this kind of like round structure. So I can see there's like a little circle here, and there's like a little circle here. And hey, look, they popped one out for us, right? Each one of these units is called an osteon. And you can see that, look, there's another one, and here's another one, and there's just all these little kind of like round units of bone. So inside of this compact bone are many, many, many osteons. And basically the way it works is that you notice in the center of each osteon is a blood vessel. So here's a little tiny artery, here's a little tiny vein, and here's a little tiny lymphatic vessel. And what's going to happen is this artery is going to provide nutrition for this entire osteon. So basically, all of the nutrients are going to move from the center out and be distributed. But there's a limit to how much a blood vessel can support. So all the cells inside of this ring are all getting their food, essentially, their nutrients, from this center artery. And over here, look, here's another one, and it's providing food to all these cells in this area. But once again, there's a limit, so we have to have yet another osteon. And then over here, we have another osteon doing the same thing. So when we look at an osteon, it's got a few parts. The central canal is the part that contains the blood vessels. So we're going to write here, contains blood vessels. And this runs lengthwise. I cannot write today. So in other words, it goes like the long way through the bone. So top to bottom in this picture. We also have these things called perforating canals that also contain blood vessels. But these guys run the opposite way. So they run crosswise. Across. There we go. They run across the bone. So in other words, these guys move from outside to inside. And so basically, if we go back to this illustration, you can see, all right, here's all of our central canals going up and down. You can see over here, there's blood vessels running side to side to connect them. And so they're perforating canals because they literally perforate in from the outside and go to the inside of the bone. Okay, so now we know kind of how blood vessels get there. Now, blood vessels are very weak. They're very soft. So we try to have as few blood vessels as possible. And that's why we have this system. So basically, it's like using, getting the most bone with the least amount of blood. The next thing is we see are these concentric lamellae. And you guys know concentric means like one layer after the other. And we've seen this word before. Lamellae means like layers. So these are our layers of bone matrix. And so let's go back and take a look at our illustration for a moment. You can see around each one of these central canals, look, here's a layer of bone matrix. Here's another layer of bone matrix. Look at this one. There's just like layer upon layer upon layer in rings of bone matrix around each one of these osteons. And so those are your concentric lamellae. And so basically, an osteon is how many layers of concentric lamellae you can fit around a central canal before they run out of nutrients. Now, within the concentric lamellae, we see these little tiny holes called lacunae, and these are basically the holes for the osteocytes. So all the osteocytes live inside the little tiny holes called lacunae, and so now look at this. This is annoying. We have lamellae and lacunae. They're very similar words. I always think of this as a cocoon. I know that's stupid, but I think of like a cocoon, like around like a, like a caterpillar. Because these are like kind of like the little shells that we find around the osteocytes. And then we also have these things called canaliculi, which this is a great sounding word, canaliculi. Literally, it's Latin for like little canals. And so these are the canals connecting the lacunae. And so basically what you have is you'll have like a lacuna, that's the singular, and then you'll have a bunch of these canaliculi, and then you'll have another lacuna, and then you'll have a bunch of canaliculi, and then you'll have another lacuna. And inside of each one of these is a little osteocyte cell just kind of like chilling out. So we just have all these cells connected. And the weird thing is, and I'm going to draw this up here, is if you look at the osteocytes, they actually have this really interesting shape. They kind of remind me of like plankton from SpongeBob, but they have like these little projections that stick out into the canaliculi. And then the next one will have little projections that'll stick out. So they literally reach out and touch the next one. And so this would be like one osteocyte, and then there would be like another osteocyte over here. And so the canaliculi are where they connect. So let's take a look at this in our picture. So we can see inside of our bone matrix, you can look and see here is one osteocyte inside its lacuna, and here's another osteocyte inside its lacuna. And then all these little lines going through are the canaliculi connecting them together, just like in my little illustration. So here's one, and you can see here's the canaliculi connecting them. And so they just kind of make like a chain of cells back all the way. You can trace this all the way back to the blood vessel. And so here's a close-up of this. So here's our osteocyte, here's our lacuna singular that this one osteocyte is in, and here are the canaliculi that are connecting it to the next cell. And basically they just make like a chain. So each cell takes some food, passes it to the next one, and so on and so forth. So you can see each one of these osteocytes are kind of spaced out, so they're not taking up too much space, so we can fill out matrix in here, but they're still able to keep each other alive. So here's another picture. I just thought this would be worth looking at. But you can see here's a Haversian canal, or what we call a central canal. And what we're doing is we're just sending the nutrition from the blood vessels through the canaliculi to a lacuna, to the next one, to the next one. And you can see they just kind of like form like a chain where each one is just connected to the next cell. And they can pass it for so many layers until they run out of room. And then you can't have any more cells here, so you have to form another osteon over here. So this would be like another osteon next door because it can't pass it that far. And then what you find out is each one of these lacuna, there's a osteocyte inside of it. So I'm going to draw a little osteocyte. And then its job is to kind of maintain all the bone matrix in this radius. And so then like here's another lacuna with its osteocyte, and it's going to maintain all the bone in its radius. And so each one of these is spread out so that you get the max matrix, which gives you the most strength possible. Because, you know, cells, blood vessels, not very tough. And so this is why compact bone is so hard, is because it is as much matrix as we can pack into a single area. And you can see this is a photomicrograph over here on the right side. So this is a microscope picture, and you can literally see the lacunae and canaliculi. And ladies and gentlemen, that's it. That's the whole presentation. So thanks for following along. Hopefully you got some good information out of that. And tomorrow we will be back to look at some more skeletal system stuff. Particularly tomorrow we are going to do a warm-up, and then we are going to look at spongy bone, the other type of bone that makes up your bones. All right, well, thanks for listening, and I'll see you tomorrow.